Hi guys, today we're going to do the chapter 1 test, and this is I'm going to do this by section, so this is part 1. So let's begin. Yeah, so I'm going to do this in parts. So this is going to be one section. So the first problem for this is part 1, question A. We have this equation and we got to solve for x. So I got to solve for x. So what am I going to do here? So we have 0.05 x plus 0.25 times 30 minus x equals 30. First step is I'm going to FOIL this out, right? That's called foiling. So 0.25 times 30 is 7.5. And then you're going to 0.25 times negative x is negative 0.25x. This doesn't change, so we just leave it as 3.3. We didn't do anything to this, so we just bring it down, right? Just bring it down. Okay, now that we FOIL it, what's my next step? My next step is group like terms. So we can, I'll circle this, we can group 0.05x with negative 0.25x. When you add those two, you get negative 0.2x. And then you bring down the 7.5 because we didn't do anything with that. So 7.5 equals 3.3. We want to solve for x, so what am I going to do is I'm going to subtract 7.5 from both sides. So this cancels. So you're left with negative 0.2x equals 3.3 minus 7.5 is exactly negative 4.2. Okay, so I want to solve for x. So this is really saying negative 0.2x times x. I want to get x by itself, so I'm not going to add 0.2x. Since this is multiplying, what's the opposite of multiplying? Dividing. Right, so when you divide this, what happens here? It doesn't cancel, it just becomes a 1, and then you're left with an x, or 1 times x, so you're left with x. And then you have to remember both sides, negative 0.2, so x equals positive 21. Okay, we're not quite done yet, even though it says our value is x equals 21, but there's another step you have to do. You have to check, right? You always got to check if it's true. So check by plugging x into original equation. Yeah, just put it back into the original first equation, right? So here's x. Put it back into this equation, right? This one right here. So when you put that back in, what do you get? Let's see. So you get 0.05 times it by x, which is 21, plus 0.25 times it by 30 minus 21, because that's my x, equals 3.3. Let's do the calculation. So 0.025 times 21 is 1.05. Okay, so what I'm going to do here is I'm not going to FOIL it out right now. I'm going to actually do what's inside the parentheses, because remember PEMDAS, orders of operation. That's why I'm going to do parentheses first. So 30 minus 21 is 9. Okay, so now it's like saying 0.25 times it by 9, which is positive 2.25 equals 3.3, because we didn't touch that. So 1.05 plus 2.25 is what? 3.3. So that's totally true, right? So we can conclude that x equals 21. Okay. That was my first problem. So let's do another one. Just let me erase this. Okay, so this is going to be part 1, question B. Let's see. We have a 5x minus 3 minus 4 plus x over 2 equals x minus 2 over 4 plus 1. Okay, so we got to solve for x. That's what we want to do. We got to solve for x. So this is an equation, not an inequality, because there's an equal sign. So how would you solve for this? So the first thing what I would do is find the common denominator. So yeah, find common denominator. Common denominator, or GCF. Okay, so to find it, we got to look at our denominator. We have a 3 here, a 2 here, a 4 here, and an invisible 1 right here. So what is my grade? Can I use 6? 6, we can multiply 3 to get something to get 6. We can multiply a number to get by 2 to get 6. We can't multiply 4 to get 6, so we can't use 6. What would be my other highest? Can we use 12? Can 3 times a number gives you 12? Yes. Can 2 times a number give you 12? Yes. Can 4 times a number give you 12? Yes. Can 1 times a number give you 12? So yes. So 12 is my biggest common denominator. So my GCF is 12. So once we found that, let me rewrite the problem again, because what I'm going to do is I'm going to multiply everything by 12, and you'll see what happens. So I'm going to use a bracket, and bracket means you have to multiply everything by that number. So I'm going to multiply by my GCF, which is 12. Okay, so 12 times 5x over 3, what you can do is you could do 12 divided by 3, which is 4 times by 5x, right? That gives us 20x. Or what you could do is do 12 times 5x and then divided by 3, you still get 20x. So either way is correct. So we're going to, over here, we're going to get 20x, right? I got 20x because I did 12 divided by 3, which is 4 times by 5, which is 20x. Now, okay, for this part, I'm going to do a minus, but I'm going to put a parentheses. Okay, so it's like saying 12 times 4 plus x over 2, right? I don't have to FOIL it out right now. You know what I can do is I could do 12 divided by 2 is 6, and then put parentheses. I'm not going to actually I'll FOIL it out later on. So this is 4 plus x, right? I got 6 by doing 12 divided by 2. Okay. Now over here, I'm going to do the same way. I could do 12 divided by 4, which is what, 3? And then you are left with this x minus 2. So I'm going to put parentheses x minus 2. Over here, 12 times 1 is just 12, right? Okay, now we can just clean this up. 20x is just 20x, right? Nothing changed. Now this negative, we can FOIL out this negative 6x, and it's negative 6. So negative 6 times 4 is negative 24. Negative 6 times x is negative 6x. FOIL this out as well, right? 3x minus 6 plus 12. Now, what can I do next? I can combine line term. Okay, so we have a right side and a left side. So let's fix the left side. We have a 20x here. I'm going to box this, 20x and a negative 6x. Those can be combined, and when you combine those, you get what? 14x. Bring this negative 24 down because we didn't do anything. Let's see here. This 3x, we only have an x, so we'll just bring 3x. But now we have a negative 6 and a positive 12. What do we get? Did I do this right? 20x minus 6 is 14x. Good. Yes. 12 minus 6 is what? 6. Positive 6. Remember, my goal is to solve for x. So, okay. I want to get to what I can do is I can move this 24 to the right. So I'm going to add 24 on both sides. Right? Notice that I'm actually canceling this out. To cancel it, I have to move. I'm adding 24. I'm not dividing it by negative 24, right? I'm not dividing it by negative 24 because you're left with a 1. We don't want a 1. We actually want the whole negative 24 gone. So that's why I added 24. Okay. So that you're left with 14x equals 3x, and then 24 plus 6 is 24 is 6 plus what? 7, 8, 9. That's 30, duh. 30. Okay, so my goal is to solve for x. So I'm going to get rid of this 3x. I'm going to actually move it to the left. So how do I do that? I'm going to subtract 3x from both sides. So 14x minus 13x is 11x. And then you're left with 30, right? Okay, now this is the part where a lot of people get confused. You got to always ask yourself, do you want to get rid of this x, this 11x, or do you want to get x by itself? I want to get x by itself, right? And now remember, this is like saying 11 times x. So if I want to get rid of this 11 because I want to get x by itself, what do I have to do? I'm not going to subtract negative 11x, right? If I subtract negative 11x, what happens here? This cancels. You're left with 0, which is what we don't want. We want x by itself. So that's why I'm not going to subtract negative 11x. But since this is multiplication, what is the opposite of multiplication? Division. And when you divide 11 over 11, what happens? They cancel, but you're left with a 1. And then you are left with that x. So it's like saying 1 times x, which is x. So that's why I'm going to divide everything by 11, not subtract 11x. And then when you divide 30 by 11, you get 2.7, which is a fraction, which is okay. But now remember, for variables, you always got to check it. So we got to check it. So what I'm going to do is going to plug x into the original equation. It would be this one, right? This is my original one. So I'm just going to plug that into that equation. So it's going to be 5 times 2.7 divided by 3 minus 4 plus 2.7. So the 2.7 is really where there's an x, right? Divided by 2 equals 2.7 minus 2 over 4 plus 1. Okay, so 2.7 times 5 is a number and then you divide it by 3, you should get 4.5 here. Now over here, what I'm going to do is do the parentheses. So you do 2.7 plus 4, then you can divide it by 2. And what you're going to get is a 3.35. But remember, there's a negative right here, so it's going to be minus 3.35. And over here, what we're going to do is do 2.7 minus 2, and then you divide it by 4. Then whatever that number is, you add 1, and you're going to get about 1.175. So 4.5 minus 3.335 is about 1.15. Does this equal to 1.75? They're very close. Now, if I rounded it to 2 decimal places, this is going to be 1.2, and this is going to be 1.2 as well, right? Because if you look at the neighbor, it's greater than 5, so that's why you round it to 1.2. So this is true, so we can say that x is approximately 2.7. Now I put approximately because remember the decimal keeps on going. It's actually 2.722. It keeps on going, so that's why I say approximately. Okay, so that was B. So let's do C, part C, part 1. So we have y equals 4x minus 9 y equals negative x plus 6. Okay, so the question says we got to find x and y, right? That's what they're saying. So this is what will we do? We won't. This is a system of equation, right? We have 2 equations. We could call this equation 1, and we could call this equation 2. So I'm not going to. What I'm going to do when you see it like this, I'm going to use substitution, not elimination, right? Elimination is like when I would use to use elimination, I would do if it's like x plus 3y equals 1 and then 2x plus y equals negative 5. That's when you would do elimination. But since the y is equal to a number, we're just going to use substitution. So substitution. So what I'm going to do is I'm going to plug equation 2 into equation 1. Right? So here's equation 2, and I'm going to plug that into equation 1. So wherever you see y, I'm going to plug in negative x plus 6, right? So plug into equation 2 and plug in equation 2 into equation 1. So this y is no longer going to be y, it's going to be a negative x plus 6, right? Because I'm plugging this into that, and then equals. We don't do anything with this, right? It's just 4x minus 9. Okay, now what to do? I want to solve for x, right? I want to solve for x. So that's one of my variables. So what I'm going to do is, let's see, I'm going to subtract this 6. So I'm going to subtract 6 from both sides. This cancels. So we're left with negative x equals 4x. And then negative 9 minus 6 is negative 15. Now I'm going to move this this 4x to the left, so I'm going to subtract 4x from both sides. Subtract negative 4x from both sides, so this cancels. So what is negative x and a negative 4x going to be? When you add those two numbers, you're going to get a negative 5x, right? Negative 5x equals negative 15. I'm going to divide everything by negative 5. And I'm going to get x equals positive 3. Okay, so we're not quite done yet. We gotta find our y variable. So what I can do is I could plug x equals 3 into either equation 1 or equation 2. So I'm going to just plug x equals 3 into equation 2. So that'll give me my y value. So y equals negative, and then we said that x is going to be 3 plus 6. So 6 minus 3 is what? 3. So we got an x value of 3 and a y value of 3. Now we got to check to see it's true. So what you could do is you can plug in x equals 3 and y equals 3 into equation 1 and 2. Let's see. So let's do equation 1. So y is 3 equals 4 times x is 3, so it's 4 times 3 minus 9. 4 times 3 is 12 minus 9. 12 minus 9 is 10, 11, 12. That's 3. That's 3. So that's true. So it satisfies equation 1. Let's do equation 2. So I'm going to plug in my x and y value. So y is into equation 2. So y is what? 3. Negative, and then our x is positive 3, so it's negative 3 plus 6. Oops, we already done that part. Let's plug it into equation 1. Put it right here. So y is 3, so it's going to be y. Oh wait, no, we already did. Yeah, sorry. Put this in equation 2. So 6 minus 3 is 3, and then this is 3, so this is true. So we can say that x equals 3, and then y equals 3. That is my final answer. Yeah. This is called substitution, not elimination. That was C. Let's do D. The question says to solve and graph. So we have 3 times 2 minus x minus 2 is less than equal to 2x minus 1. So what are we dealing here? Are we dealing with an equation or system of equation? I mean, in an inequality. Sorry. So are we doing an equation or an inequality? We're dealing with inequalities, right? This is an equality because there's no equal sign. If it was an equal, it would be an equation, and if it's less than or greater than or less than equal to, these are all what is it? Eliminate inequalities there. These are all dealing with inequalities. So first we got to solve for x. So what I would do first, solve for x. So what I would do is FOIL this out, right? So this is going to be 6. 3 times 2 is 6, and then 3 times negative x is negative 3x. We didn't do anything to this negative 2, right? So just bring it down. The sign hasn't changed. 2x minus 1. So the sign, what I mean by sign doesn't change is when are you multiplying or dividing by a negative? That's when you change the sign. No, we're not. Okay, so let's simplify the left side. So over here, we have a 6 and a -2. That can be simplified, but this -3 is just, it is what it is, because we didn't, there's no other x's, so it's -3. What is 6 minus 2 is +4, less than equal to 2x minus 1. This is probably the most simplified it can be, right? Now, let's see here. I want to solve for x, so what I can do is subtract 4 from both sides. This cancels. The sign does not change because we're not multiplying or dividing by negative. We are only subtracting, so it doesn't change. So this is going to be -3x less than equal to 2x stays the same. So we have a -1 and -4. That's going to be -5. Now what? Let's move this 2x to the left. So I'm going to subtract 2x from both sides. This cancels. So what is -3x minus 2x? -5x, right? You could think of it as you have -$3 and then you have another -$2 on the bank. So how much do you owe? -5. But since there's an x, it's -5x. Sign does not change, less than or equal to -5. Okay. Now what we have to do is solve for x. So I'm gonna, I want to get rid of this -5, so I'm going to divide everything by -5. But what happens to the sign? It changes because we are dividing by negative. You only change the sign when you're multiplying or dividing by negative. So it's going to be x is greater than or equal to +1, because -5 times -5 is +1. Now the question says we got to solve for x and then we got to graph it on a line. Graph it on a number line, right? So how would I graph it on a number? There's actually, you could do the dark circle and we can also do the bracket. So how I would show, so here's 1, right? One option is doing the dark circle because there's an equal sign, right? Whenever there's an greater than equal to, less than equal to, that gives us a dark circle. If there's no equal sign, if you're just left with greater or less than, you can use open circle. So there's an equal sign, so it's greater. So we're going to use dark circle, and then it's moving to the right because it's greater than. So you just put the arrow like this. Or what you can do is do brackets. Brackets is when you have greater than or less than equal to. And then you have parentheses if it's just greater than or less than, no equal sign. So we're going to use brackets. And then and it's pointing to the right. So that's two ways you could graph it on a number line. Okay. Okay, now let's do an absolute value. This is D. Okay, so yeah, that was D, so let's do E. So we're going to deal with absolute value. So it's absolute value of 3 minus 2x is less than equal to 5. So remember, the question says we got to solve for x and graph. On number line. So solve for x and, okay, so when we're doing absolute value is whenever you're doing an absolute value, you gotta always check outside the absolute value. If there's anything outside, like a number, like a -3 right here, if there's a number, anything outside the absolute value, you gotta take care of that. So if there was pretend if there was a -3, to get rid of that -3, you would have to divide everything by -3, right? To get the absolute value by itself on the outside. We don't care about the inside for right now. So since we have nothing out on the outside, we can break the problems into two parts. So we can rewrite this as 3 minus 2x is less than equal to 5. And then our other equation was going to be 3 minus 2x. And then what I do is I flip the sign. This is going to be flipped, so it's going to be greater than equal to. And then I'm going to add a negative. So this positive 5 is going to be a negative. So it's going to be -5. Now we got to solve for x for both equations. So over here, I'm going to subtract 3 from both sides. This cancels, right? So you're left with -2x is less than equal to 5 minus 3 is what? 2? Yes, 2. And then I want to solve for x, so I'm going to divide by -2. So what happens when you divide or multiply by negative? The sign changes, so it's going to be x is greater than equal to -1, right? 2 divided by -2 is -1. Okay, now let's focus on this equation. So first step, I'm going to subtract that, get rid of that 3 by subtracting -3 from both sides. This becomes -2x is greater than equal to, what is -5 and a -3? That's -8, right? Then I'm going to divide everything by -2. So what happens when you divide it by negative, the sign changes, so this is going to be less than equal to. -8 divided by -2 is +4. So we have two solutions, x equals -1 and x is greater than equal to -1, or x is less than equal to +4. So we got to graph it on a number line. So put my smallest number on the left, so my smallest number is -1. And then my biggest number is +4. Okay, so we could do two ways. We could do the circles and we could do the brackets. So since there's an equal sign, this -1 over here has an equal sign, so we're going to do dark circle, right? And then since it's moving, it says greater than, you're going to move it to the right. And over here, the 4, this 2 is going to be a dark circle because it has an equal sign. And then it's going to the left because it says less than. So they connect. This is what's called an AND problem, an AND absolute value because it connects, right? This is an AND. If you're curious what an OR is when it goes on the opposite side. That's what an OR problem, an OR absolute value. And then the other way you could do it is using brackets. So we're going to use brackets, not parentheses, because there's an equal sign. So it's going to be bracket, bracket, and then you connect them together. So that's how you solve and graph an absolute value inequality. Okay, a few more, and then I think 2 more problems, and then we're done for this part. So that was E. So this is going to be F. So we have x squared plus x is less than 20. So this is, you got to look at this graph. This is not an absolute value. This is not what kind of graph would this is what's called a polynomial, right? So yes, so if question says we gotta solve for x in graph. Yeah, so this is a polynomial, and then so when you're dealing with polynomials or rational inequalities, you're gonna do what's called the test point method. This is only when you're dealing with polynomials or inequalities. Okay, so an example of a polynomial would be like x squared plus 3x plus 2, right? This is a typical polynomial graph, right? This is the non-standard form, right? This is the non-standard form of a no, this is just polynomial. So the first step is what I'm going to do is put it into standard form. So what I mean by standard form, you just simply have to get the right side 0. Get right side 0, right? That's what I mean by standard form. Next step is find all the zeros. Find all zeros, right? So what I mean by find all zeros is solve for x. Find all zeros. And then the third process is choose a test point. Okay, so let's see here. So first step is I have to get rid of this negative 20, move to the left because we want this to be 0. So it's going to be x squared plus x, and I have to put it in order, right? From highest degree to lowest. So this is 2, this is a 1, and then this negative 20 has a 0 degree. And then it's less than, this cancels, so you're left with 0. Good. Okay, so I'm going to actually put it, so this is the inequality form. But now I want to put the reason why, and then I'm going to put it in another form. I'm going to put it in equation form, and you'll see why. So in equation form, it's going to be x squared plus x minus 20 equals 0. You'll see why, because when we actually have to test it on a test point, this is the equation we're going to use. So the next step is find all zeros. So what I'm going to do is, for the equation form, I'm just going to factor and then solve for x. So x. So okay, so we need to find two numbers. When multiplied gives you negative 20, and when added gives you positive 1, right? So I'm going to use positive 5, and I'm going to use negative 4. The reason, because 5 times negative 4 is negative 20, so it satisfies this part. And then when you add 5 and negative 4, you get positive 1, so it satisfies this part. So this is just simple factoring, and then when you solve for x, you're going to get x equals negative 5, and x equals positive 4, right? When you set those two to 0, like this, subtract 5, subtract 5. That's how you get x negative 5, and then add 4, add 4. That's how you get x equals positive 4, right? So that's how I get, so these are all my zeros. Okay, so now let's put it on a number line. My smallest number is negative 5, and my biggest number is positive 4. Now, we look at this, the inequality equation. Do you see this less than? That less than means we only care about the negative numbers, right? That's we only care about the negative numbers. So when we test my point, if we get we're going to get a positive or negative. When we test points, you're going to either get a positive or negative number. So in this graph, we actually have three parts. We have this part from negative infinity to -5. That's my first part. And then my second part is from -5 to +4. That's my second part. And then my third part is from 4 to +infinity, right? So now we're going to do a test. We got to do a test point. I need a number from -infinity to -5. What number can I use? I'm going to use -6, right? -6. So I'm going to plug in -6 into this equation, the equation, not the inequality. So what I'm going to do is going to do f of -6. When you get that, you're going to get -6 squared plus -6. That gives me -20. And that gives me, what does that give me? +10. So we don't really care about the number. We only care if it's a positive number or a negative number. So +10 is just +10. So we're going to put a plus here, plus here, plus here. Now we only care about the negative, so we're not going to put this, you'll see what I mean. We're not going to put this in our boundaries. So this part is positive. For the first part is positive. Now let's focus on the second part. We need a number between -5 and +4. So I'm going to use 0, right? I'm going to plug, my test point is 0. So I'm going to plug in 0 into this part. And when you plug in 0, you're going to get 0 squared plus 0 minus 20. And you're just going to be left with -20. So this -20 is a negative number. So we're just going to put negatives, negative, 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 negatives, right? Good. Now my third part is I need a number between 4 and higher, 4 and greater, bigger than 4. So I'm going to use +5. So when you plug in 5 into the function, you're going to get 25 plus 5 minus 20. And when you do all the work, you get +10. So you're going to get positive numbers. Now remember, when we put this in interval notation, remember we only care about the negative numbers. So wherever there's a negative, so we only care about this region from -5 to +4. So when we put it in our interval notation, now let's see here. It's from -5 to +4. But remember, do you see this is a less than, there's no equal sign. So are we going to use dark circle or open circle? We're going to use open circle, right? Because there's no equal sign, or you could use parentheses, right? It's the same thing. So my interval notation is from -5 parentheses, -5 to +4 parentheses, because there is no equal sign. There's no equal sign on our inequalities. Okay. And then that's interval notation. And now if you graph that, how would that look like on a number line? You're going to do open circle, and then it's just going to connect, or you can use parentheses. So this is actually this part here is my final answer. I got to put it in interval notation, and then I got to graph it on the number line. This is just this is not our answer. This is just the test point method. This is actually my final answer. This is the correct answer. Okay, so this was just a regular polynomial. Now let's actually deal, our last one is going to deal, so this is my last one. And this is going to be in a rational inequality. Okay, so question says solve and graph. And then I want to put it in interval notation. Put it in interval notation. So we have this inequality, x squared minus 3x minus 10 over 1 minus x. It's greater than equal to 2. So this is a rational equation, right? Rational. And the reason how I know it's a rational, because it's under P over Q form. It's a fraction, right? That's how you know it's dealing with rationals. So my first step is put it into standard form. So standard form is when you have to get the right side 0, right? So I have to get rid of this, move this 2 to the left. So put it in, that's what I mean by standard form. So subtract -2 from both sides. So you're going to get x squared minus 3x minus 10 over 1 minus x minus 2, and then this cancels, and the sign does not change, so it's still greater than equal to 0. So this is in standard form, but we kind of have a problem, right? We got to find our common denominator, because you can't just subtract 2. So our common denominator is, there's a 1 minus x, so we got to multiply this part by 1 minus x, top and bottom. So this is going to be minus, and then I'm going to put parentheses, and then I'm going to FOIL this out. So 2 times 1 is 2, and then 2 minus x is negative 2x. But here's the thing, now you got to FOIL out this negative. So this is going to be negative 2, and then 2 negatives becomes a positive, so this is positive 2x. Then bring this along, because now you have a common fraction. So this is x squared minus 3x minus 10 all over the common denominator, which is 1 minus x, greater than equal to 0. Now let's clean up the numerator. So let's see, what can we combine? We only have one x squared, so it's x squared. Let's combine the x's. So we have a 2x here and a negative 3x. So what is that going to be? Negative 3x plus 2x is a negative x. And then we have a negative 10. I'm going to circle this. And then a negative 2. So what's that going to be? Negative 10 and negative 2 is negative 12. Yeah. Greater than equal to 0. And then don't forget the denominator. Okay, so now we got to find our zeros. So our zeros. So we have two parts, the numerator and the denominator. These are all going to be our zeros. Let's figure out what our zeros is going to be for our numerator. So to do that, you set the numerator to 0, right? X squared minus x minus 12 equals 0. When you factor this out, you're going to get x, and then let's see, 4 and 3. I'm going to use -3, -4, and +3, because -4 times +3 is -12, and when you add that, you get -1. So my x values for the numerator is 4 and, what is it, 4 and -3. Now remember, we can't forget about the denominator, so we got to set that to 0 to get my other x value, so it's going to be 1 minus x equals 0. So I'm going to subtract -1, subtract -1, I get -x equals -1, divided by -1, -1, I get x equals +1. So my other x value is x equals 1. But note yourself, this 1 will never be included. You're always going to use a dark open circle. For this, for the x values for the numerator, we're going to actually use dark circles because there's a greater than equal to. The reason why we're going to use 1, the one that's going to be an open circle, when you put it on the number line, is because where do we get that? We got it from the numerator. Remember, P over Q, we cannot get a number 5. Let's say you use 5 over 0. We can't get that because that would be undefined, right? That's why this 1 is not included, because this 1 would make it undefined. So that's why we're going to only use open circle for that. So what I mean, so let's actually graph it on the number line. So what are my x's? So what is my smallest one? The smallest one is -3. And then my other smallest one is going to be 1, right? 1 here. And then my biggest number is 4. So -3, like we said, we got it from the numerator. That is included because there's an equal sign. So we're going to use a dark circle. And then for the 1, we are not going to include that because we got it from the denominator, and we can never get it. We can never get an undefined, because if you put that to 0, so no, it's going to be an open circle. Just remember, denominator is always open circle, because that would make it undefined. And then 4, we got it from the numerator, so it's going to be dark circle. Okay, now remember, also, okay, so this is my inequality form. Now I got to write it in the equation form, because in equation form, you got to. The reason why I'm going to put this in equation form is when you test the point. So remember, the equation form is when it's equal to 0, and then the inequality form is when there's a greater than or less than equal to. Okay, so now so how many parts do I have? I have this part. Part 1 is from -∞ to -3. Part 2 is from -3 to +1, and then part 3 is from 1 to +4, and then part 4 is from 4 to infinity. Now, notice that it's greater than or equal to. We only care about positive numbers. Positive numbers. So keep that in mind when we do the test point. Okay, so when we use the test point, we're going to use this equation. So I need a number to be between -∞ to -3. What can I use? I'll use -4. So I'm going to do f of -4. I'm going to put this into this equation. So when you plug in -4, what do I get? When I do all the work, I'm going to get 8/5. So if you plug in -4 into this equation, you're going to get 8/5. 8/5 is a positive number, right? So put a positive here. Positive, positive, positive. Now I need a number between -3 and 1, +1. What can I use? I'll use 0. F of 0. So when you plug in 0 into this equation, I'm going to get -12. -12 is a negative number, so I'm just going to put negative, negative, negative. Okay, now part 3. I need an equivalent number between 1 and 4. I'll just use 2, positive 2. When you plug in 2 into this equation, I'm going to get positive 10. 10 is positive, so I'm going to put positive, positive, positive. And then over here, I need a number between 4 and greater somewhere, so I'm going to just use 5. F of 5. When you plug in 5 into this equation, I'm going to get negative 2. So this is going to be negative, negative, negative. So we only care about positive numbers, right? Positive integers. So we only care about boundary 1 because this is positive. And we only care about boundary 3. So in interval notation, let's see here. It's going to be from negative infinity. So infinities always goes with parentheses. And it's going to be 3. And then since this is a dark circle, we're going to use a bracket. Because dark circle and brackets are the same. And then we're going to union, because we got to include this part. We're going to do from union 0 from 1 to 4. So remember, this is 1, which we got it from the denominator, right? It's not included because it makes it undefined. So we're going to use a parentheses, because parentheses means not included. 1 and then 4. We're going to actually, for the 4, we're going to use a bracket because we got it from the numerator, which is included. Right? We got it from here, the numerator. So that's why we're going to use bracket. Okay, so that's my graph on interval notation. Now, how would I graph it? This interval notation on the number line? It'll look something like this. Here's negative. Sorry, this should be negative 3, not positive 3. So here's negative 3. And here's 1, and here's 4, right? So negative 3, we can use bracket. And then we know it's going from negative infinity to negative infinity to negative 3, so we're going to go this way. Or you can actually do dark circle, same thing, and put it that way. And then from boundaries 1 and 4, 1 is an open circle, so you're going to use a parentheses, and then 4 is a bracket. So, and they connect. Or what you can do is do an open circle and a dark circle, and then you can connect. So those two ways to graph it. Either way is correct. So this is actually, my final answer is like this. The interval notation, and then graph that interval notation on a number line. The whole point of this part is this is the test point method, and then this tells us my correct boundaries. Okay, so that wraps it up for this part of chapter 1. I'm going to do this in several parts.